Hello everyone, I'm Zhou from Michigan State University. Today I would like to share our collaboration work with my advisor, Dr. Qiben Yan, Dr. Yan Shi, and Dr. Lichao from Lehigh University, titled DoubleStar Long-Range Attack Towards Depth Estimation-Based Obstacle Avoidance in Autonomous Driving System. There are different autonomous driving systems nowadays, such as drones, autonomous driving vehicles, and robotic cars. For the safety and security reason, obstacle detection and avoidance play an important role. There are different types of sensors in the autonomous driving system, such as LiDAR, radar, camera, and ultrasonic sensor. Cameras are especially popular due to its low cost and wide usage. There are two types of cameras, monocular camera and stereo camera. A monocular camera has a single lens and a single image sensor, whereas a stereo camera is a type of camera with two lenses and a separate image sensor for each lens. There are some recent work trying to attack cameras. Contactless attack use laser to make the denial of service attack. Ghost image use a projector to inject an image into a camera. And split-second phantom attacks project the image to the physical world to fool the object detection system. Besides, some recent work also try to attack drones. One type of attack uses acoustic signal to interfere the IMU on the drone, leading to a denial of service attack. The attack distance is around 10 centimeters. The other type of attack is trying to continuously control the drone over attacking its downward-facing camera. The attacking distance is around 3 meters. However, there are some limitations of the existing work. First, all existing attacks towards autonomous vehicles target monocular cameras. Therefore, in this work, we are trying to attack stereo cameras and identify the stereo cameras' vulnerabilities. Second, all drone attacks have limited attack range. In this work, we propose DoubleStar to control drones continuously over a long range. So what is DoubleStar? DoubleStar is the first black box and long-range attack against stereo vision-based depth estimation in obstacle avoidance system on autonomous systems. Before I go into the attack design, I would like to introduce some background knowledge of stereo vision-based depth estimation. Stereo vision-based estimation borrowed the idea from the human binocular vision. As you can see in this figure, object P and object Q are sensed at different locations of the retina, resulting in the different depth of the two objects. Similar to the human binocular vision, stereo camera has left and right image. Based on the triangulation, we can mathematically calculate the depth of an object, which denoted as Z here in the third figure. However, stereo vision-based depth estimation are not exactly the same as the human perception. It often matches the similar features, such as shapes, colors, with high confidence and stereo correspondence. Here is an example. In the left and right images, I manually add a meaningless image patch. It causes a fake depth in the depth image. Besides, there is an interesting effect in the optical imaging, which is called lens flare effect. Lens flare effect is a phenomenon caused by the scattering and reflecting of a bright light through a non-ideal lens system, where several undesired artifacts appear on an image. Here is an example. The light source is sensed by the CMOS sensor. However, at the same time, the light is scattered and reflected multiple times, and cause a green small orb on the CMOS sensor as well. This is what we call lens flare effect. Here is an example in the real life. This is a light source, which we call glare here, and this is the light source. The other one is orb, which is caused by the lens flare effect. We also investigated using the different attack angle and attack distance. We still can see the orb in the second and the third figures. Besides, we noticed that the glare and the orb has a relationship, which is their coordination are central symmetric with each other. For example, if the glare has a coordination of A and B, then the orbs will have the coordination of -A and -B. Now let's look at the design of the double-star attack. The basic idea of double-star attack is using two light sources to project to the stereo camera to create fake depth. We have two types of attacks here. The first type is called beams attack, which is based on the glares as we introduced before. The second one is called orbs attack. This is based on the orbs. We also designed three types of attack patterns, and I'll introduce them one by one. The first attack pattern is called X-shape attack. We have light source P and Q and a stereo camera here. P is pointing to the right camera, while Q is aiming at the left camera. The original circle represents the appearance of the injected light, which is glare as we shown in the previous figure. And the dotted red circle stands for the position of the light source, which is not aiming at the camera. As a result, the Q in the left image will match with the P in the right image as a stereo correspondence. This is what we captured in the real life. This is P and Q. As a result, we can have a fake depth in the depth map. And we also can clearly see the fake obstacle in the 3D point cloud. The second attack pattern is the Trapzoid-shape attack. In this attack scenario, P is targeting to the left camera, whereas Q is pointing to the right camera. Therefore, P in the left image will become very brighter, and Q in the right image will become very brighter. And central symmetrically, there will be an orbs happens in the left and right image. This is what we captured in the real life. These two orbs will match each other with a stereo correspondence and output and fake depth here. This is what we can see in the 3D point cloud. A fake obstacle is created. The last attack pattern is the triangle-shape attack. Triangle-shape attack is trying to use the P and Q covering the left and the right cameras at the same time. Ideally, it should look like this. However, when we project the light to the stereo camera, we can observe a huge coverage area of the light. So in this case, we cannot guarantee exactly the same amount of light covering the two cameras at the same time. As a result, the attack will be transferred into this or this. So this is the three types of attack. And now let's simulate our attack using the Ardupilot and AirSim. AirSim is an autonomous system simulator created by the Microsoft, which is used to collect virtual environment data in our simulation. And Ardupilot is a popular drone project, which is used to simulate DoubleStar on the drone. This is a normal communication between the Ardupilot and the AirSim. However, in our simulation, I manually put an attack phase, which we can manipulate the depth and send back to the Ardupilot to fool its control and behavior. This is one of our simulation results. The flying environment shows that there is no near obstacle along its flying path. In the Ardupilot, we can see that without attack, the hiding direction and the flying direction are the same. However, at the attack starting point, we observe a fake obstacle at its near right. Therefore, the drone tries to fly to the left and avoid the obstacle. We also demonstrate our attack in other attack scenarios, such as sudden stop and shaking. Please refer our paper for more details. We also test our attack physically. This is the experimental setup. This is a DJI drone and the light source projector. This is where the stereo vision sensor is, and we also tested our attack on two stereo cameras, which is ZED camera and Intel RealSense camera. We first investigate the fake depth range on the DJI drone. The maximum attack distance we can say is 15 meters at night and 8 meters in the day. And the range of the fake depth is 0.5 to 16 meters. This range covers all the possible depths that can be sensed by the DJI drone's obstacle avoidance system, which makes real-time drone control possible as we demonstrated in our simulation. The fake depth matches with the expected value. For the calculation of the expected value, actually we set up a mathematical model in our paper as well. Please refer our paper for more details. The second thing we investigate is the range of the attack distance and angle. From the left figure, we can see the stronger projection power leads to longer attack distance. In the second figure, we can see the attack angle is very wide. During the day, the maximum attack angle is around 29 degrees, and during the night, the maximum attack angle is around 48 degrees. Based on these two figures, we can see the attack at night is easier than during the day. We also attack other state-of-art DNN-based stereo depth estimation. We put the real-time collected data to the stereo variant-based depth estimation algorithm, and we can say in the depth map, we can successfully create fake depth in the algorithm at most of the cases. Here is one of our attack demonstrations, which we are trying to drift away the drone from its original path. This is the attack setup. DJI drone, attacker, and the real depth is 7 meters. Without the attack, we use the active track mode, which allows the drone to track a marked moving object at a constant distance. You can say the DJI drone is tracing the subject normally. However, when we start our attack, the drone will be alternated. You can see the attack is start. Avoiding obstacle is showing on its control panel. And once the subject is moving, the drone is drifted away to another direction because it senses a fixed obstacle on its original path. In conclusion, we present our attack, DoubleStar, which is a new type of attack towards the depth estimation-based obstacle avoidance on autonomous driving vehicle and drones. We also introduce two types of attack, beams attack and orbs attack, with 3 different attack patterns in DoubleStar to generate a large range of fake depth. We also demonstrate our attack on different devices equipped with stereo camera, which we can achieve up to 15 meters attack distance at night and 8 meter attack distance during the day with a wide attack angle. Our future work will be evaluating our DoubleStar attack on autonomous driving vehicles and the design defense mechanisms. Thank you for your listening, and I'm ready to take your questions.